Hey, how's everybody? Welcome to the first video of Parabolic Throw and Projectile Shot. Well, you can find this topic with this probably with these two names. Okay, so this is the problem one. Okay, I got the initial velocity of a parabolic throw that is 25 meters per second at 70 degrees. Okay, and I got these questions. Okay. So before I answer those questions, well, I'm gonna make a little drawing over here of parabolic throw. So I'm gonna imagine that there is a person that throws an object, something like this, and the object goes in a parabolic trajectory. Okay, so it is very important to say that this velocity that they give me, okay, that is the initial velocity. Okay, so remember, well, this is the initial velocity and goes something like this. Oops, goes something like this. Okay, this is the initial velocity, but that is the resultant vector. And remember that every vector has two rectangular components, bx and by. So this is the initial velocity in x, and this is the initial velocity in y. Okay, and also we got an angle, and remember the angle is measured from 0 degrees, and this is the initial angle. Okay, so the object, well, is going to have different stages. For example, the object is over there, and then it's over there. Okay, and in every stage, or at every moment, the object, in this case, I don't know, a stone, is going to have the velocity vector or the resultant vector, something like this. And I'm going to call this velocity. Now it's not initial because the initial is only this one. Okay, that is the initial velocity. And in every moment, I'm going to have two rectangular components, that is bx, and in this case it's going to be by at every moment, and this is going to be the angle. I'm not going to call it initial angle because the initial angle is over here. Now if you see, well, what I recommend you to do is, for example, this is the drawing. Now what I do is that, for example, is that I divide this motion into, okay, oops, into two segments. Okay, so I call this the segment number one, and I call this the segment number two. How I identify them? Well, the segment number one is when the object goes up, okay, and the segment two is when the object goes down. Okay, and for example, at here, over here is the object. Well, here I got the maximum high. Okay, and well, just remember, this first segment could be treated as vertical throw, and I'm talking in y dimension, vertical throw. And the second segment can be treated as free fall. And if you remember, we already saw those topics. If you are new to the channel, well, I recommend you, this video is in a playlist called Physics 2. So in that playlist, I cover all the topics, okay? Free fall, vertical throw, motion in one dimension, and so on and so on and so on. If you want to learn more about it, well, I invite you to add that playlist in your favorites. Okay, so remember, okay, in vertical throw, remember that the velocity at the maximum height, but I'm talking about the y velocity, because remember that in this case I'm going to have two components, the x component and the y component. Okay, so the y component, the velocity at the maximum height, okay, the velocity at maximum height in y is 0 meters per second. Okay, well, I guess I got too much zoom. Okay, I'm gonna do this. The velocity in y at the maximum height is 0 meters per second, because that is the velocity in y when we are working with vertical throw. Okay, so when we solve problems like this, it is like the same as vertical throw. I can choose the segment number 1 or I can choose the segment number 2, but I repeat, this is in y dimension because this motion is in 2 dimension, x and y. Okay, so remember, in segment number 2 now the velocity would be something like this. That would be the velocity, the velocity vector. And of course, I'm going to have two rectangular components. This is going to be bx, and this is going to be by. Now, you need to, well, I hope you notice that now by goes down, okay? And this part goes up. And then at the second segment, velocity in y goes down. And if you remember the reference system, everything that goes up is positive and everything that goes down is negative. So in this case, we're gonna do it again. We're gonna consider that. That means that in the segment number 2, the velocity in y is gonna be negative. In the segment number 1, the velocity in y is gonna be positive. And remember, here, this is where the motion starts. So here it's gonna have initial position that most of the times is 0 meters, okay? And here, at this point is where the motion ends. So here I'm gonna have final position, okay? How much is that? Well, that depends on the velocity, the initial velocity, and the initial angle. But also, for example, you can find this as, okay, final position, or total distance, or range. Okay, you can find it like that. Okay, if you find it like range, well, the letter is going to be R. Okay, now remember, just as the horizontal throw, the acceleration in x will be 0 meters per second square. So that means that the velocity in x will be constant. Okay, that's very important because we are going to consider exactly the same things. This gonna be treated, could be treated as vertical throw, this free fall, and x, well, could be treated as horizontal throw. Okay, but I'm talking when I'm talking about the acceleration, that in this case the acceleration in x is 0. So that means that the initial velocity in x equals the final velocity in x. So that means that I can just write velocity in x. Okay, so let's go back to the problem. If it's needed, well, I'm going back to the drawing to make some notes. Now, if you see, well, I got the magnitude of the vector and the result and the angle of the vector. Okay, so what I need to find is the initial velocity in x, this one over here, and the initial velocity in y. So if you remember from the first videos, I'm gonna put a card over here. Well, there is a formula that says something like this: initial velocity in x equals the initial velocity that multiplies the cosine of the initial angle. And the other formula says initial velocity in y equals the initial velocity that multiplies the sine of the initial angle. Okay, so let's find them. I can do it in the calculator. Okay, so I'm gonna open my calculator. So b, the initial velocity, is going to be 25, that multiplies the cosine of the initial angle, that is 70. Okay, equals, okay, well, that number is the initial velocity in x. So I'm gonna save this value in my memory A. and I'm gonna write it over here. That is 8.55 meters per second. Okay, 5505 meters per second. Now, and I'm gonna say that this is saved in the memory A of my calculator because I'm pretty sure that I'm gonna use it again. Now, let's find the initial velocity in y. Okay, well, initial velocity in y is gonna be 25 that multiplies the sine of 70 degrees equals, okay, so I'm gonna write it 23.49 23 meters per second. Okay, and this value is going to be saved in the memory B. Shift STOB. Okay, and so this is the letter A. Okay, so I'm gonna circle it. This is letter A of my problem. Okay, now letter B, it says total time or range or maximum height. Okay, so I'm gonna write a formula, and this formula comes from the formula of horizontal throw. Okay, because remember that if you see this second part of the problem, the angle, this angle over here is 0 degrees. Okay, so the vector goes something like that. Okay, that's the velocity vector. What is the angle? It's 0 degrees. So this could be considered as horizontal throw. Okay, so from horizontal throw, and I recommend you to watch that video if you don't remember, if you haven't seen, there is going to be a car over there. There is a formula that says position equals the velocity in x that multiplies the time. Okay, the position in x, I repeat, equals the velocity in x that multiplies the time. Remember that the velocity in x is going to be constant. Okay, so for example, if I want to find the range, so the range, I need to find the final position. So in order to find the final position, for example, I can do this. This is the segment number 1, this one over here. So I'm gonna have a time 1. Okay, that time 1, I'm gonna write it over here, time 1. Okay, so that time 1 is the time that takes this object to reach the maximum height. Okay, and also I'm gonna have time 2. Time 2 goes here from here. Okay, time 2 is the time that takes the object to reach, well, to go from maximum height to the initial position in y, to return to the original height. Okay, and total time, well, will be from this point and this point over here. Okay, got it? So if I want to find the total time, the total distance or the range, well, in that case, the formula that I need, well, it's gonna be the same formula, but it's gonna be final position or total distance, as you wanna call it. For example, I can do this. Total distance equals the velocity in x. Well, I already got the velocity in x because remember, velocity in x is gonna be constant. So initial velocity in x equals the final velocity in x. So I'm just gonna call it velocity in x. Okay, equals velocity in x that multiplies total time. Okay, I need the total time, not time 1 and not time 2. Okay, and just like vertical throw, I hope you remember. If you don't remember, I recommend you to watch that video. Just as vertical throw, time 1 equals time 2, okay? And total time equals time 1 plus time 2. Okay, in paper, I mean theoretically, of course, that is not going to happen in the real world because there are more variables. Okay, so from that equation, okay, do I have total time? Sorry, total distance? No. Do I have bx? Yes. Total time? No, I don't have total time. Okay, so I cannot use that equation. So if I return to my drawing, I told you that the second segment is going to be treated as free fall. So I recommend you to watch my video of free fall. And in free fall, we got many equations. So I'm going to write the equation, for example, the equation for maximum height in free fall. Okay, I'm just gonna call it, if you want, maximum height or total height or maximum height, as you wish. Okay, I got too much zoom. Maximum height equals minus the acceleration, okay, minus the acceleration in y that multiplies the time. Okay, but got a question. What time? Okay, what time? Okay, this time over here. Okay, because in free fall, let's say that I'm on segment number 2. I'm here. Okay, I'm here and the object will go down. Okay, so I need this time, not the total time. I need only the time that the object is over here. So the object is going down. Okay, so I only need the time that takes the object from the maximum height to reach the ground or the original height. So I'm gonna call this time 2 because this is the time of the segment 2 raised to the square over 2. Okay, and now I call this maximum height, but of course this could be known as initial position of the segment 2, because if we go to the drawing and we divide this drawing into segments, well, that means that in this segment over here, that point is the initial position of the segment 2, and that is the maximum height. Okay, maximum height. Okay, so this is the segment 2 and this is the initial position. Remember, the initial position is where the motion starts. So from this point over here, the object will go down. So that means that in the segment number 2, this will be the final position of the segment number 2. Okay, just as the analysis that we did in free fall. Okay, so I'm just gonna call this, but I'm gonna make a little arrow over here, and I'm gonna say that this is maximum height. Okay, maximum height. Okay, so from that equation, well, let's say, do I have maximum height? No. Do I have acceleration in y? Yes, that's the value of the gravity. Do I have time? No, I don't have time. So I cannot use that equation. Okay, I can't use that equation. So okay, now let's go to this to the first segment in y. Okay, it's vertical throw. Okay, vertical throw. So I recommend you to watch, for example, the video of vertical throw. So if you remember, there was an equation that says acceleration in y equals final velocity in y minus initial velocity in y over time. Okay, But if we're talking about the segment number one, okay, this is the initial velocity in y, and the final velocity in y of the segment one, okay, this is the initial and this is the final, okay. The velocity in y at the maximum height is 0. So if I consider that, well, this is going to be canceled, okay. So I'm gonna have this acceleration in y equals negative the initial velocity in y over time, okay. But what time? What time? Okay, that time is going to be the time that takes the object from this point to reach the maximum height, because I'm considered that I'm going to reach the maximum height. So in that case, it's going to be time 1, okay. So from this equation, I'm going to do this. Do I have acceleration in y? Yes, it's minus 9.8 meters per second square. Do I have initial velocity in y? Yes, I just found it. Do I have time 1? No, I don't have it. So from this equation over here, I'm going to find time 1. That is the time that takes the object to reach the maximum height. Okay, so that equation, if I just isolate that equation, will be time 1 equals negative initial velocity in y over acceleration in y. Okay, so let's do it. I guess initial velocity in y, I got it in the memory B. Okay, so let's do it in the calculator. So fraction negative the initial velocity in y, so negative alpha b over the acceleration in y, that is going to be minus 9.8 meters per second. So equals, and this is time 1. This is the time that takes the object to reach the maximum height. Okay, so that will be the half of the total time. Okay, so I'm just gonna write over here that time 1 equals 2.39 seconds. This value, I'm gonna save it in the memory C, because I'm pretty sure that I'm gonna use it. Okay, I'm gonna write here that this number is gonna be in C, but I need total time. Okay, so I'm going here. Well, I'm gonna continue over here, but I'm gonna use another color. Okay, so total time equals, if I'm saying here that time 1 equals times 2, and it's gonna be the addition, so total time is gonna be 2 times time 1. Okay, so total time equals 2 times c, 2 times alpha c. Okay, boom, and that is total time. So it's going to be 4.74 43. Sorry, 79. Sorry, I made a mistake. 79 43 seconds. And this is letter what? That's letter B. This is letter B. I'm gonna circle it. Oops. I'm gonna circle it with red. And I'm gonna say that this is gonna be in memory D. Shift STO-D, because I'm pretty sure that I'm gonna need it. D. Okay. Now that I got the total time, I can go back to the formula that comes from the horizontal throw. Now I have, now I have total time. Now that I have total time, I can multiply it by the velocity in x, so I can find the total distance or the final position or the range, as you want to call it. Okay, remember that we are going to use total time, not time 1, not time 2. Time 1 is the time that takes the object to reach the maximum height. Time 2 is the time that takes the object from to reach from the maximum height to reach the beginning. Okay, so the initial height. Okay, so I'm going to return here and I'm going to use this equation. So let's do it in the calculator. Whoops, yes. Bx, I got it in A. So alpha A times total time, I got it in D. Total time times D, okay? So the answer will be the range. So I'm gonna write it. Total distance, final position, or range is gonna be 40.9941, okay, meters. And I'm going to circle this answer, and this is letter C. Okay, I'm not gonna save this value because I'm pretty sure I'm not gonna need it anymore in order to find another answer. So I got letter A, letter B, letter C. Now I need to find the maximum height. In order to find the maximum height, now I can use this equation over here, maximum height. Okay, so now I got time 2. Okay, now I got the time 2. And you can say, no, we don't have time 2. We got time 1. If you remember, we got time 1. Yes, but remember that time 1 equals times 2. So time 2 is the time that takes the object from maximum height to reach the initial height. Okay, so with this equation, I can find the maximum height. Okay, this equation comes from the video of free fall. Okay, so let's do it. Fraction negative times the value of the acceleration, that is minus 9.8 meters per second square, and that multiplies the times 2, that is the time 1, and time 1 is on memory C, times C, but I guess that C is raised to the square, as you can see right here. So raised to the square over 2. Okay, so equals, boom, that is the maximum height. Okay, so let's do it. Letter, I'm just gonna write it here. Okay, and you can write this maximum height equals 28.15 75 meters. Okay, I just want to what I got in C, yes, is 2.39. Yes, it's 2.39, and I just want to test a new alpha V. What I got in alpha V, yes, over 9.8. Okay, I just wanted to be sure. Okay, so I'm gonna circle this one, and this is letter D. Now, okay, that is the end of the problem, but what if I want to find, okay, total time 1 is 2.39. okay, what if I want to add another question, letter E. Okay, velocity at 4 seconds. What is the velocity of the object at 4 seconds, or at the 4 second? Okay, but which velocity I'm talking about? I'm not talking about the velocity in x. And I'm not talking about the velocity in y. I'm talking about this velocity, the resultant vector. And if I'm asking you to find the resultant vector, I need you to find the angle too, magnitude and direction. Okay, now you need to see something. 4 seconds, okay? The total time is 4.7. So the object at second number 4 is going to be over here. Okay, if you see, it's going to be in the second segment. So that means that the velocity in y is going to be negative. Okay, so I need to find the velocity. I need to find the velocity and the angle because I need the magnitude and the direction. And if you remember, there is a formula that says velocity equals the square root of bx raised to the square and plus by raised to the square, and this is going to be inside of a square root. Okay, if you remember, well, in this case, in this particular case, well, bx is constant, so I already got bx. How much is bx? Okay, well, bx is 8.55 meters per second. 8.55 meters per second. Okay, but how much is by? I need to find by. How much is by? I don't know. I don't know because by is the only one that is going to change. For example, first is going to be increased, is going to be like this, but every time that passes, the velocity in y is going to decrease due to the fact of the gravity. Okay, at this point, the velocity in y is going to be 0, and then it's going to be decreasing. So what is the value of the velocity in y at 4 seconds, at the second number 4? Well, I can find it with this equation. Acceleration in y equals final velocity in y minus initial velocity in y over time. Okay, now I need to find final velocity in y. Final velocity in y, well, it's not final velocity. I mean, to us is final velocity because it's the velocity at 4 seconds. So I'm just going to call it by. Okay, so by is going to be acceleration in y that multiplies time plus the initial velocity in y. Well, maybe I just made the isolation so quickly, but time goes multiplying and minus initial velocity in y goes to the other side, positive. Okay, so velocity in y is going to be minus 98. Well, I'm gonna use another color. Oops. Velocity in y is going to be minus negative, well, negative 9.8 meters per second. Time, how much time? 4 seconds. Plus the initial velocity in y, and I just got that one. That is this one, 23. 23.49. Okay, plus 23.49 meters per second. Okay, let's do in the calculator. So minus 9.8 times 4 plus 23. How much is 23? Well, I need to see. Okay, it's in letter B, and it must be negative because it's in the segment number 4. Now in the segment number 4, the velocity is negative. So how much is this? Is negative. Okay, so velocity in y at the second number 4 equals minus 15.76 meters per second. Okay, and this is going to be saved in my memory M. Okay, because I don't have more memory, more letters in my calculator. Okay, this is, wow, this is on M. Okay, so now I got bx and I have by. So let's do it. Let's find b, the velocity vector, is the resultant vector. So a square root of bx. How much is bx? Well, it's in memory a. So square root of a square plus the memory m square. Okay, and that would be the magnitude. Okay, 17. Okay, the velocity vector equals 17.8841 meters per second. But also I need to find the angle. Okay, let's go back to the drawing. Okay, I got here. Now I got the magnitude. Now I need the angle. But remember, I don't want this angle. I need the angle that is measured from 0 degrees. So I need the total angle. So in order to find the total angle, I need to identify the quadrant. So if you don't see it clearly, well, this is my Cartesian plane. The first quadrant, second quadrant, third quadrant, and fourth quadrant. So in the fourth quadrant, if the negative that I just find is negative, I need to add 360 degrees. Okay, so that's a topic that we already saw in the first videos. Okay, and we are going to use this equation, this formula. The angle equals, oh, I got too much sum, sorry. Okay, the angle equals the tangent inverse of by over bx. So it will be shift tangent fraction. By is in m over bx, that is in memory a. So the angle is going to be negative because I'm in the fourth quadrant, equals. So let's go back to the drawing. Okay, this angle over here is minus 60.43, this one. So what I'm going to do, I'm going to add 360 degrees so I can find the total angle. Okay, so let's do it. Whoops, oops. So that angle is going to be added plus 360, and that will be the total angle at 298.5617 meters per second. And I'm gonna circle this one, and that is letter E. Okay, so well, this was the first problem of parabolic throw, and well, I just combined the problem with theory. That's why the problem was so long. But I'm pretty sure, I hope that you guys understand, because I needed to explain the equations and so on. But if you see, those equations come from previous topics that we already saw. So I hope you kind of understand. So in the next video of parabolic throw, well, I'm not going to spend too much time explaining the equations. I'm just gonna write them, and I'm gonna say these equations come from this topic and the other one comes from this topic. Okay, so I hope you guys understood, and I hope I see you in the next video. So take care. Bye bye.